Today we will build single layer neural network and multi-layer neural network using TensorFlow. We'll import TensorFlow as TF. We'll be using functions like TF constant, TF placeholder. These functions are very useful and are used here. So first we will be starting with computational graph. We are making graph A and graph B, and we are adding to get the graph C. The values are assigned for the making of these graphs. When we use the print function, we don't get any value, and that is the difference between this TensorFlow and the NumPy bundles. To get the value of C, we need to run the session, and we need to use the tf.session, this function here. Another way of doing the computational graph is using the TF placeholder. So here we are using TF placeholder for making the graph of A and B, and again adding these two graphs to get the C, and we are running the value, and we are running the session, and during the session we are assigning the value for the graph A and graph B, and that is the difference between these without hard coding process from the last one. This is very common, and we will use this method of making the graph for simple neural network and next multi-layer neural network. We are starting with this by importing pandas as PD. We are importing here pandas for loading the data. The data is not cleaned. We need to use the exploratory data analysis, that is the EDA, and we get a cleaned data set. In this data set we have the features like month, date of the week, class of travel like first class, 2A, 3A, and booking status. In the booking status we get that 0 and 1. 0 is assigned for general waiting list, and 1 is assigned for Tatkal waiting list. So our target is to get the charting status, that is waiting or confirmed. So we need to build a single layer neural network to predict that whether the booking is confirmed or still waiting using these four features. We have four features here, so we are using these to make X, and our target is Y. We are using that scikit-learn here to split the dataset into train and test. Training dataset is 80% and test is 20%. Here we are looking into the computational graph, that the value of X is multiplied with the weight and added with the bias to get the linear function. So here we are making the computational graph by using tf.placeholder. We are using 4 features, 4 inputs, and 1 for target. We are assigning the weight and bias variable. These are parameters, so these parameters are different from hyperparameters. So this linear function we are getting y hat, so we are here. So this linear function in this network will be changed into non-linear, and this is needed because for real life problem non-linear functions are performing better. So we are doing this by using the activation function. Here, the activation function, we are using sigmoid. We have other functions like tanh, softmax, and rectified linear units. The functions are different, and we will take care of those activation functions like they should be used as derivative for backpropagation. So here the forward bus that we are getting from this output, nonlinear output, to another nonlinear output by again multiplied with weight and added with the bias, and this output and the weight is not same in the network, and that is changed based on that derivative of the activation functions. the the backward During the backward propagation or back propagation, those activation functions, derived form of activation functions, are giving that the value that is different from the target. So here we are getting the error, and that error is leading to change these weights. So these weights are changing due to this forward pass and backward pass. Now this error that we are talking at this moment, that the loss, the error, or the cost for one layer will be averaged out to multiple layers in this network. And here comes the cross entropy concept. The probability distributions of target value and predicted value. These probability distributions are different, and if we sum by multiplying this target and log value of predictions, and if we average it out, then we'll get that cross entropy value. So this cross entropy value is the loss of the network or the error of the network. So our objective is to make this loss minimum. So this minimization of the loss can be done using the optimizers. There are several optimizers like gradient descent optimizer, Adam optimizer, and to get this optimized value, we are passing the parameter of loss and the learning rate. Here learning rate is high parameter. So we have discussed the parameters like weight and bias previously. That is different, that is not fixed. Here the high parameters learning rate 0.001 and the iteration number 500, those are fixed, and these fixed values are the reason of good training or bad training. So these parameters, high parameters, assigning is important, and that is different from parameters. So parameters value A and the parameters value are changing, like weight and weights are changing throughout the network, but high parameters are fixed. Now coming back to the optimizer, here the optimizer, the gradient of descent optimizer is used, and there are three types of gradient descent optimizer. One is stochastic, gradient descent, another one is batch, another one mini batch. So stochastic, the basic one or the beginning of the gradient descent, the concept starts with the stochastic SGD. So this gradient descent is very much computationally expensive. So we think of the batch gradient descent, but the negative side of the using of batch BGD is that it is very memory crunching or very memory hungry, because the whole data set, training data set, goes into that memory. And if it is big size, the size of the training set is big, then it hampers the training, or it hampers the convergence of the training. Now from the gradient descent, or from the optimization of that of the loss, the cost function, so we are now going into the training part. So here we are using that session tf.session. We are running the session and we are giving the input of x train and y train. We are feeding it, and we are building the model. That model, we are getting the accuracy of the model for the training set, and we are comparing with the test set. Now we are going into the another concept of multi-layer neural network. Here we have the two hidden layers, and these hidden layers are built using, here we are building these layers, and this layer is built using that using the ReLU function. So previously we have used the activation functions like sigmoid, and here we are using the ReLU. Now we are importing matplotlib, TensorFlow, NumPy, and we are loading the data. Here the data is handwritten digits, and the size of each digit that is 28 into 28, that is 784 features are the input. So here when we are building our graph, we are giving the input of 784, and we have 0 to 9, the 10 digits. So the 10 classes here the input for making the graphs. And we discussed that we are using the ReLU function, activation function, to make that nonlinear in output. And here we are making this function by using this function network. And again, the entropy is used to minimize our loss. So cross entropy is used here. The TensorFlow has tf.inn.softmax cross entropy with logits. Other entropies are also available like sigmoid, tf.inn.sigmoid, and we are using here the optimizer, the gradient descent optimizer, and that learning rate here also used. But these hyperparameters, when we are using the hyperparameters here, we are using the batch size 128 that was not there for the single neural network. Here we are using this because we are using mini batch gradient descent. So mini batch gradient descent is used here, and we can get that good accuracy of 97%. So to recap our discussion, we are making first the graph and we are making the linear function using those graphs. The linear function is not useful for the real world, so we are making it non-linear by using activation function. This activation function goes forward and it changes with the value of the weight, and the weights are changed due to the back propagation. So the loss between the target and that the prediction value, that loss, there is a reason for changing of the weight, and this loss of one layer can be summed up with another layer. So the summing up and making the average of all losses or the loss of the network can be computed using the cross entropy. And this cross entropy, the cross entropy output, that is the loss of the network, can be minimized using the optimizer. And next, we would be running this network for training. Before training, we will assign the hyperparameters. The parameters are already assigned, so here we will assign, now we will assign that hyperparameter and we'll train. And we can go beyond this session with application of other functions of Tensor API, TensorFlow API, that is TF extension, that is TF estimator, TF layers. We can use Keras for making CNN, RNN, and LSTM architectures.